Thank you very much for attending today's webinar. My name is Dennis Roberts, President of Energy Efficiency Done Right. And we'll be talking today about Inflector as an energy efficient measure. First, I'd like to let people know about my background and why I can talk about such important topics. Again, I am President of Energy Efficiency Done Right. I'm also President of Advantage Window System. I do serve on the board of the National Fenestration Rating Council Task Force for Interior Attachments. I am a consultant for energy efficiency and window issues for Gerson Lerman and TGI Networks. And I am a published author and a speaker on special events. This is an article I wrote. I've been published in Energy Pulse and Energy Central. This was an article I wrote on temperature disparity and how to deal with that, because that's a big problem in buildings. I'd like to get right into our information. The truth is that the U.S. military is the largest consumer of energy in the world. That according to U.S. military energy consumption facts and figures. 25% of the military energy is used to power and heat buildings and facilities. And of course, one thing we want to talk about is a new energy efficient measure. Now we'll get to why the Inflector can be such a good option. Energy loss through glazing or windows is the largest and most variable loss in buildings, and it has major implications on energy consumption and peak heating and cooling loads. Net zero is the military sustainability goal, and it's going to be hard to obtain, but with diligent planning and hard work, it is obtainable. Getting back to the windows again, according to ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, windows are responsible for 53% of a building's heat loss. Now that's amazing considering that windows are only about 18% of that surface, but they're responsible for 53% of that heating loss. Put another way, Lawrence Berkeley National Laboratory did a study, and what they found out is in the year, I believe it was 2009, that windows were responsible for 2.15 quadrillion BTUs of heating energy consumption and another 1.48 quadrillion BTUs of cooling energy consumption. This is only the energy lost through windows, and we're talking quadrillions there, much bigger than the stimuluses and the money spent that you hear on different issues. We're talking about, again, 2.15 quadrillion BTUs of heating energy consumption, 1.48 quadrillion BTUs cooling energy consumption. The technology that you're going to be looking at today has the potential to be the primary source of energy demand reductions globally and a major source of decreased emissions, because the cleanest energy is the energy you conserve. Window insulators should and must be a part of energy independence. And we're going to show you how we can prove these facts. Let's talk a little bit about energy efficiency, because we believe that this is the way it should be looked at. Energy conservation, energy efficiency is the base of the pyramid, because that energy that you save, again, can be the most useful, the least harmful to the environment, and the most productive. So the energy efficiency we're trying to obtain the most use of energy possible, the most efficient use. Here you're going to see that what they're saying is that a tremendous amount of money could be saved by utilizing new technologies to lower energy usage, and this could have a dynamic impact. In fact, what we found out is that according to an in-depth study by Architecture 2030, that if we doubled if we put on 30 new nuclear power plants and we double our offshore drilling, that's going to be equal to 3% of our needed energy consumption in the United States by the year 2030. However, if we make our buildings and homes more energy efficient, we can obtain 11 times more energy. Consider the infrastructure and cost of all these new nuclear plants and doubling offshore drilling, and both of these have had tremendous impact problems in this last few years. So we can obtain 11 times more energy with less infrastructural cost just by being much more energy efficient. So what are the keys to a sustainable energy future? Well, it depends upon 4 actions: a move toward a lower carbon economy, reduced dependency on fossil fuels, significantly improved energy efficiency across all sectors, and the development of affordable energy solutions. Don't waste it, insulate it. And what we're talking about is insulating all aspects of the building envelope, most especially the windows that are a major source of energy loss and consumption. I know of no product in the world that's been as extensively tested as Inflector. There's been no product that we've seen out there that's been tested not only in more ways but in more different places. Inflector has been tested multiple times in the United States and in Canada. It's been tested in the UK, Australia. It's been tested in Dubai. It's been tested in Singapore, and we just got tests we're waiting for results from on China and the Czech Republic. And of all these tests have all come to the same conclusion. The product works like we said it can, and it's a phenomenal energy efficient measure. So let's go over some of those tests and show you why Inflector is an important part of enveloping. First of all, there was a test done up in Canada. It was a third-party test done on a building that had a tremendous amount of infiltration. Now, infiltration can be 6 to 9% of our total energy cost. That's the leakage of the controlled air that we've heated and treated to the outside or from the outside in, which is infiltration. This test was done by Canada consultants on a building. They installed Inflector. They tested intensively. They found out that Inflector reduced that exfiltration by 64.8% to 71%. The comment was Inflector insulators provide a good air seal. So what we immediately know is that on older window stock, Inflector can be a tremendous enhancement to a major source of energy consumption, which is infiltration. Yellow Solar Laboratory did a test, and what they wanted to do was a study of the solar absorption potential for Inflector. So they did this test where they wanted to find out how much energy can Inflector in the solar loading mode create. The test was done in depth, and what they found out is that the Inflector has the ability in direct sunlight for each 16 square foot of glass to produce 2,096 BTUs per hour. That is the equivalent of a 600 watt heater. So you can imagine for each window you'd have the same consumption benefits of a 600 watt heater. 12 windows in direct sunlight on a cold but sunny day, that's the same amount of 600 watt heaters. So that's a tremendous amount of free heat. But this is a double bonus because when the Inflector's in a solar loading, whereas normally in the cold weather each window is going to lose that 53% of your heat, now instead of losing it, it's gaining it. So now instead of having a tremendous heat loss, you've got a heat gain where you had a heat sink. So again, a 4x4 16 square foot of glass has the ability to produce much heat as a 600 watt electric heater, and at the same time it's reducing your infiltration and stopping your solar sun gain and your UV. Texas A&M did a study in 2002 on the effects of Inflector on thermal properties of windows, and what they found out is that the U value of the window was improved by 54% in the winter and 50% in the summer. So automatically by adding the Inflector, not only are you dealing with these other issues, but you're adding insulation. You're increasing it by half again by installing Inflector. That's a Texas A&M study. So Northwest University did a study, and what they found out is how much energy consumption can you reduce by installing Inflector? Again, this is a third-party test done by Northwest University in South Africa. They took 3 offices that were identical. They put Inflector roller shades on one. They put Inflector insulating panels on another and left the other one uninsulated. The Inflector insulated offices averaged 30% less energy use than the uninsulated office. And recently there was a study done in Dubai, and on a side-by-side test of buildings, they had small buildings with glass, with equal amounts of glass. They put the Inflector on the one, they didn't on the other, and the Inflector reduced demand created for air conditioning by 41%, and the Inflector was able to keep the thermostat temperature consistent, while the building without the Inflector was not. The temperature would rise during the heat of the day, 3, 4, 5, 6 degrees Celsius, while the Inflector stayed consistent and at the same time used less energy. We utilize an EDTM glass test kit to test Inflector to compare heat absorption through glass. And with that, it shows you single pane, double pane, or low E were all tested, and what they found out that the Inflector significantly reduced the heat transfer through any type of glass. With a single pane glass, it went from about 80% of the heat passing down to about 20%. Double pane, it dropped from about 61% down to 17%, and with low E, it dropped from about let's see, that was the amount was about 60% down to 17%. Tremendous improvement. And again, we use EDTM glass test kit that's used by the National Fenestrating Rating Council. Ortec Laboratory did a test on the thermal transmittance. What they found out is the Inflector, under daytime summer solar loading, your solar heat gain coefficient, it would reduce it by 49%. Under nighttime winter thermal conditions, heat loss, it had an immediate effect of reducing the thermal transmittance coefficient by 37%. So immediately by adding the Inflector, you're improving the thermal performance, and that has a whole lot to do with comfort. This is the meter test of the EDTM test equipment that I was talking about for both heat loss and heat gain and UV blockage. To the top left, you're going to see the amount of heat blocked. And again, this is heat blocked in either direction because heat goes to cold. So in the summer, the heat's trying to come in. In the winter, the heat's trying to get out. So the heat is traveling in either direction. The blue represents a single pane glass, how much heat is blocked. The red is the Inflector with the Inflector insulator. Then next you have the double pane, how much heat is blocked in blue, and then with the Inflector, and then the low E, and then how much is blocked with the Inflector. So what you can immediately see is with the Inflector on a single pane glass is much more energy efficient than a brand new low E window, which is very impressive. And again, look at the UV, the same as the heat blocked with UV, UV with Inflector. And what you can immediately see is the Inflector, again, is much more efficient on a single pane glass than a brand new low E window. It's a significant improvement to any window. There was a study done on the effects of solar heat and comfort. And what they found out is that, and this was called the Center for Built Environment, that the Inflector was dramatic in improving the things that made people uncomfortable where they lived or work. The primary reason people are uncomfortable in the summer is long-range radiation that is absorbed and irradiated by the window, and solar radiation absorbed increases the window surface temperature, which will transmit to the people inside and make them hotter. The number one reason people are uncomfortable in winter is what's called a convection loop. The glass is cold, the warm air hits the cold glass, it falls, it pulls more air behind it, and it creates its own air current. So the three reasons why people are mostly uncomfortable in any building are due to the windows, and Inflector improves all of those conditions. Okay, here you got basically how Inflector deals with winter heat loss. Basically, you're going to have what's called a piling effect, that cold air again bumps up against the glass and it's transmitted because glass is conductive. With Inflector, you're putting a barrier between the glass and the inside. Now you're insulating that space, not allowing the inside air to make contact with that cold glass. Here's a picture of Inflector looking out on a window in the winter time. And then what we've done is we've done an infrared analysis of those same windows. Now this right here is on a day when it was 13 degrees and the infrared picture temperature on the glass was 16.3 degrees in one spot, 18.7 degrees in another spot. Yet on that inside, on a day it was 13, the temperature on the Inflector inside that same window on that same day was 64.4 degrees, within 3 degrees of the temperature. This isn't considering the solar loading. This is just the insulation effect of the window. So without the solar loading, it gives you the effect of a insulated wall on your window, which is the main source. Now here's a picture of the solar loading. And this is really dynamic because on this day the outside temperature was 24 degrees. The thermostat was the temperature of was holding at 72.9 degrees, which was the temperature on the wall. The temperature on the Inflector on a day when it was 24 degrees was 112 degrees Fahrenheit. Now, without the Inflector, the temperature on that glass would be 40 degrees, approximately 40 degrees. And it would be creating a convection loop and losing energy. But now, instead of losing energy, it is actually about 40 degrees warmer than the thermostat temperature, and let's see, from 40 and 70 degrees warmer than the temperature on that out of the inside of the glass. So that is the solar loading. So the goal to do is to achieve super efficiency in housing or buildings. How do we achieve that? Insulation, windows, target energy use, and appliances. Inflector deals with all three of these right here because it's insulating the windows, and it's targeting energy use because 71% of all the electricity in America is used to heat and cool and make residents of buildings comfortable. Here's a picture of an installation of the Inflector on the Officers Club, which is called the Gateway Club at Lackland Air Force Base. And I want you guys to view this because what you're going to be able to see is the actual way the Inflector looks. Now, they had a big problem in this building because there's 107 panes of glass across the front of this building. You can see the west sun is just about to hit those windows when this picture was taken in mid-afternoon. When they did a lot of functions in the Officers Club, and they'd always have little pre-event get-togethers inside this foyer, and it was always the most uncomfortable part of this building. It was the hottest in summer, and it got very hot at times, and it was the coldest in winter just because of this amount of glass. So they installed the Inflector and insulated it, and this is what you got. What you're going to see there is two situations here. On the left, I want to call your attention to there's Inflectors on 5 of these windows. It's on the 3 on the right and the 2 on the left. All the ones in the door and this top left one are not insulated with Inflector. What I want you to quick call your attention to is you can barely see outside because of the glare, but through the Inflector you can see the tiles on the outside concrete, you can see the trees, and if you were there in person you could also see the sky. Now the picture on the right, all this bank of windows on the right has no Inflector, but the one here beside the door does. Now look at this carpet. You cannot even see the color from all the sun streaming in through that window, but behind the Inflector you can clearly see the color of the carpet. That's because we're taking and taking 67% of all that solar heat and reflecting it right back outside. And at the same time, we're stopping all that radiant heat, about 75% of the radiant heat that comes off the concrete and asphalt outside. Now, all this heat that's streaming in is heating up the inside air, but it's also being absorbed by that carpet and re-radiating long-range waves, which are called greenhouse heat, which are opaque to glass. They will not go back through it. So Inflector is dealing with the infiltration, the solar gain, the thermal properties, the infiltration, all at the same time. And we know of no other product that does that. This is the little Army posture statement from 2011. And I think it's probably paralleled across some of the militaries. But the idea was to aggressively support research, development, and acquisition of advanced technologies to increase energy security and sustainability. And that is something that Inflector can be a vital part of. I know there's goals in military building management to reduce the energy consumption on a yearly basis, and nothing can do that better than Inflector because it does deal with all these different issues. So we love this. We love measure, evaluate, and verify. And when they did the larger building installation at the Lackland Air Force Base, which is called Security Hill, they did a real strong analysis, and they calculated that they were going to reduce energy consumption by over $100,000 a year in that building. It had a lot of problems. It was single pane windows. It had a lot of framing on it. That frame will cause solar bridging. So it had infiltration, had very little insulation, and it had very conductive convective glass, and it was a big source of heat loss. So I like these aspects of the measure, evaluate, and verify because we're anxious to do some benchmarking. We've got some software to calculate what that energy savings to Inflector should be, and we'd like to verify it through benchmarking on consumption. The problem we've had, we did a big installation at Fort Huachuca, Arizona, gave them immediate improvement on comfort levels. Immediately their air conditioner started recycling again, which it wasn't doing. But none of the buildings there were individually metered. They were group metered, so they weren't able to measure those. So we weren't able to verify exactly what the energy consumption is. They had the same problem when we did Security Hill because it had a lot of different units on there, and also it's they're very, very secure buildings, so it was very difficult for us to get the ability to benchmark it. But we've been doing installations at Lackland, we've been doing installations at Randolph, and each time they've come back and did multiple more buildings with us. And now we've done our first installation at Fort Sam Houston, which has a lot of historic buildings, and it's ideal for Fort Sam Houston because with historical buildings you cannot change out the windows, but since we go behind the windows, you can utilize them in those situations. So windows are your primary source of heat loss, they're your primary source of infiltration, and they're your primary source of discomfort, and Inflector can deal with all those issues very well. So now I'd like to get to some of the nitty-gritty of our presentation here, which is performance specifications and how we found out the different things that are on here. Solar heat gain coefficient. Again, this was the Ortex laboratory test, so the strong reduction in solar heat gain coefficient. Infiltration reduced from 64.8% to 71% according to Scanner Consultants. Solar collection, that's the solar loading benefit. Hewlett Solar Laboratories, 2,096 BTUs per 16 square foot of glass. And on some of these buildings, you can realize how much free heat that can amount to. U value, Inflector improved the U value by 54%, according to Texas A&M. Energy use reduced by 30%, according to the South Africa study. UV reduced by up to 90%, according to EDTM UV transmission meter studies. Solar gain, according to the EDTM testing, reduced over twice the solar gain of a double pane window. Thermal properties, Ortec Laboratories reduced the thermal transmittance coefficient by 37%, and on and on. So again, these are real situations, and when you compare that to replacement windows, you'll not get the comfort or the payback out of replacement windows that you can get with Inflector. So we're going to be wrapping up in a few minutes, and then we're going to be taking any questions. There's a chat bar on the bottom of your little side panel that you can type in any question. I'm going to try again and see. I opened your mics, but I wasn't hearing anything, so I don't know if you have access to speak to us, but if you can, if you don't, we'll take your typed in questions. This is a restaurant where they were getting a lot of glare, and they were getting a lot of heat, and they were getting a lot of reflection off the water. This is by the little private lake. And so this is the way the restaurant was most of the time. It had these shades. Well, I'm going to tell you, shades are not an energy efficient product. They have energy efficient components. So now you have no efficiency and no view. This is what they got when they put the Inflector in. Now they've got the view that the people came there for, and they've got greater efficiency. So even though from the outside you can't see in, and it's got a lot of reflectivity, let me tell you, this is a solid piece of material. So even though you can see out of it, it's done with perforations and laminations. So that's how it deals with infiltration. This is what you can get, and this has tremendous energy efficiency, much more than the shades, much more than a double pane or even a triple pane gas-filled window, because of this ability to insulate the windows. So right now, this is our new campaign that's coming out. Now you can make your windows part of your efficiency solution, and that's what Inflector can do for each of your military branches. This is contact information from myself and Keith Roberts, and then I'm going to be taking your question in a few minutes. And again, I can make all these tests available to you, but number one, what we want to do is we want to have an opportunity to prove to you that Inflector can help you exceed your goals for energy consumption reductions. And it absolutely can. Having said that, gentlemen, I'm going to, let's see, let me try Michael again. I'm going to try and, Michael, can you hear me? Looks like you're on a phone. Roger, can you hear me? Okay, I'm not having ability. I haven't got this recorded. But if you look down at the bottom is our chat bar, and you can type in any of your questions there. So let me see what we've got here. Okay, Michael says he can hear me. Okay, okay, Michael's listening on the phone. And Roger asked, are you going to be covering costs? Inflector has three different types of, actually three primary types of installation. The panels, which we mostly use in a commercial or military governmental application, the roller shades, and the vertical shades. And I'm going to pull up some of these for you to look at just shortly. The cost is going to be very much dependent upon the type of installation and the complexity. We just did do a building here at Fort Sam Houston, wherein they had a drop ceiling, so the windows went further up the side of the wall, and then that made the windows very difficult to, the insulators difficult to install because there were permanent cubicles in there. So there's a lot of complications that can affect the price, and I can give you some rough numbers, but that's what they're going to be. It's going to be dependent, again, the installation. What I can tell you is this, is that an Inflector will cost less than replacement windows and will be 4 to 5 times more energy efficient. Right now, the experts are saying that a brand new low E window, the estimated payback is going to be in 18 years. Inflector payback is less than 6 years, and sometimes significantly less. And again, it's according to all those factors. In fact, when we create a spreadsheet to calculate energy savings, what we have to weigh into it is, of course, the climate, the type of windows you have, the amount of glass you have, orientation of the building. We have to know all the different factors, how the building is used, what the consumption is. So we can supply cost, but again, it's going to be cheaper than a replacement window and much more energy efficient, but it's going to be very much dependent upon the type of installation. Let's see here, Roger's got anything else? Okay, Michael, I'm going to have to show my ignorance as to what ATFP, I haven't seen that before, ATFP. Roger, I will share with you what we've done is I'm going to wait for Michael to give me an explanation of what this term is. What I'm going to let you guys, anti-terrorism force protection. This goes inside the window and it doesn't add any, it adds a security benefit because from the outside you can't see in during daylight hours. If it's backlit, you can. So, and we've also found out it does make it significantly harder for a couple of reasons to try to listen into conversations inside these buildings because of the nature of the material. But we are working on a high security version of it by laminating it into, because a big problem with bulletproof glass is conductive and convective, and that any kind of glass, particularly thicker glass like that, will absorb and hold heat. With the Inflector, we could keep most of that heat from being absorbed by the glass, so we could keep the heat inside also. So getting back to Roger's question, we formed a task force. It is called the Energy Savings Calculation Task Force. That task force has created a spreadsheet where you put in all the dynamics of the building, the square foot of the building, the square foot of the glass, the type of the glass, the orientation of the building, exact geographical location on the earth, because we can use ASHRAE temperature things. And from that, we've estimated energy savings. And then what we want to do is we want to have all types of buildings and all types of climates where we made that estimation on the front. Then we benchmark it and we showed the actual savings, because it's going to be impressive, because windows are the thermal holes in buildings. And when you put in a double pane or a triple pane or a gas-filled window, it's still glass. And glass is convective and glass is conductive. And we can create a trap barrier inside of that glass and totally change the dynamics of it. Change the infiltration, change the solar heat gain coefficient, change the heat loss, change the heat gain, because when Inflector is reversible and it's in a solar collector or a solar rejector mode, and it's going to significantly change that. So yes, I will send everybody who would like a copy of the spreadsheet, an example of how we did that, how we do those particular things. Okay, I'm going to go back again to this slide right here, because what we've actually also done is we've done a comparison between different items like replacement windows and Inflector for what they did for certain aspects. Because, for example, a low E window, the low E is for emissivity. Emissivity is very, very important. Reflectivity and emissivity are very important in making the Inflector work. But on a window, the low E is a sputter coating. So it's just a coating that they put on the glass. With Inflector, it's the real thing. It's aluminum. And aluminum is a low emissivity product, and it's one of the lowest available. So that's why it's not allowing that heat transfer. Consider this: when people are cooking their Thanksgiving turkey, they'll take and they'll put a piece of aluminum over the breast of that turkey during the final stages, because why? The breast is drying out and it's cooking quicker than the rest of the meat on the turkey. So you can imagine that the aluminum that we have in the inflector works the same way. It's not allowing that heat to transfer in at the same level, and it's making everything much more efficient. So each of these aspects here, inflector will work better than any window tint, any replacement window, any solar screen, uh, any window treatment, meaning things that you're going to buy. Again, it could be curtains, drapes, any of these things. So inflector works significantly better. Which you can see the types of installation. And feel free to put any more questions in there. Okay, here you have the inflector panels. So you can see them in the summer configuration is this here, and the winter configuration is here. Now, when you reverse the thing, now the reflective side is pushing the heat back in, and the dark is absorbing it and radiating heat through those holes. Here is an installation at Fort Sam Houston where you're seeing inflector on the window on the left and no inflector on the right. And you can see all this light streaming in that you don't see behind the inflector. So what you see is the blue in the sky that you can't see through the other side during the day because of glare. Well, that glare and that light right there is representative of solar heat gain. Okay, then you're going to see down here, these are inflector vertical shades. Now, the vertical shades and the roller shades are not as energy efficient as the panels, although in South Africa they gave the same energy savings. But the only difference between the panels and the vertical shades and the roller shades is you don't have a sealed window cavity. This creates a trapped airspace, and it does improve infiltration, but the inflector panel reduces it much more dramatically. Here's the roller shades. So let me get back over here. See if we get one question. Have you done any projects in California? No, we have not to date. We're just setting up our manufacturer out there, and we're working on an installation at Amgen, which is, I believe, in Thousand Oaks. So we will have an installation out there very soon. Michael's got to go. Michael will be looking forward to hearing from you. Thank you for coming. We are recording this presentation if you want to hear some more information. Roger, can you hear me? Robert, can you hear me? Robert Black? Okay, you may not have the microphone there either. Well, gentlemen, that is my information. We do not have a California installation yet, but we're anxious to do tests with anybody. We love for them to do side-by-side tests. There's two big reasons why inflector, why people would want to buy an inflector. First is energy efficiency, and the second is comfort. The comfort change is dramatic because across the building you do have temperature disparity. You have your corner offices or your east offices or your west offices, and they're not going to be the same temperature as your interior offices because of the amount of energy lost through the windows. But when you insulate those windows, you make them much more like your other offices, and they produce great results. So Inflector will lessen the load demand on your heating or cooling system significantly, because the reason that heating and cooling system is working so hard is simply because of the energy loss in those areas where there's glass. And again, a lot of people don't understand the dynamics of glass, but let me put it very simple. Everything in a building is rated in R, but windows are rated in U. R is resistance to heat transfer. U is conductivity. We don't want conductivity. We want resistance to heat transfer. But windows are very conductive. But if you change your U factor and make it comparable to your R factor, then a plate glass or single pane glass, it would be R1. Most of your walls are R24, R26. Plate glass or single pane window is going to be R1. If you're a double pane, it's going to be R2. Again, 2 compared to 24, 25. Even a double pane low E window is about 2.5. So you're looking at not very good efficiency for any type of window, and that is on your, again, the U and R is your insulation ability, the ability to keep heat in or keep heat out. And windows are the biggest source of infiltration and the biggest source of heat loss, and they are the thermal hole. With that, I'm going to conclude my presentation. We did record today's webinar. If you'd like to see it, I've also got the PowerPoint if you want to see that. We work with a Dropbox. We have our certification and testing. Again, I don't know of any window or window treatment or window application product that's been tested in so many different ways in so many different parts of the world as Inflector has. And we've got installations all over the world simply because Inflector works. And Inflector works like nothing else out there. It's going to pay for itself in energy savings, and it's going to help the people be much more comfortable. So having said that, I'm going to conclude our webinar. Thank you very much for attending, and let you know we have these resources available either in our Dropbox, our YouTube video landing page, and we got all these. And if you haven't seen our website yet, please look at inflectorglobal.com, and you can find a lot more of this information. Thank you again, and we look forward to giving you more information in the future and hopefully meeting you one day. Have a great day.